I think gonna be starting soon. Let's see if this thing works, if we are actually aligned with the stream. I suppose the YouTube streaming should be working, unless it does not. Okay, I think a few people are still waiting. Hey guys, let's give the others a few minutes to join. I'm gonna check briefly if I'm audible or not. Can you guys hear me? Can you confirm on the chat? I have you open there. I suppose there's a delay here. Can validate whether I can. Okay, great. Hey, Kuba. I suppose there's a Nice. Okay, so I can see you in the chat. Let me see if I can reopen the diagram I had saved yesterday. I'm still learning this whole streaming thing, so if you guys have to forgive me any bloopers or mistakes I make here. If you guys have any feedback for me after or during the session, just do tell, and I'll try to fix it later. This should okay. I think the OBS is actually acting out here because it shows my old screen. So I think there's something wrong with the OBS. Yep, there's definitely something wrong. I'll have to reconnect shortly. I'll probably reopen the OBS because this is my old screen that I'm seeing here. Just give me a second, okay? Okay, guys, I think this should be better right now. Let me see if I can see my screen. It should be visible. Seems on the right. Okay, this should be actually a live view that I see on the screen. Let me just reopen the chat so I can see what you guys are doing and saying. Apologies for these interruptions. Okay. Okay, we are back on track, I guess. Hey, Prashant. Okay, guys, we can start, I think. So I did a bit of streaming on Sunday, and I was talking about the basics of how the Kafka protocol works. And I think it can be time for us to evaluate some KPIs and how the producers and consumers and what's the latency actually about in the in this area. Let me just validate quickly that you guys can see the screen. You should be seeing that. Okay, there's a lot of people here. Hey guys. Okay, can you guys see this screen that I'm streaming here? It should be visible, the drawings, the diagrams. If you can confirm, that would be great. I can see it in my preview, so that should be fine. Nice. Okay, so talking about Kafka and the producer and consumers and load testing. First of all, to get started, this stream and this video is sponsored by my wife. She's looking after the kids, so make sure you guys appreciate all the help from your family when you do this stuff like that. You guys can leave her a comment that you guys appreciate it. She's gonna be watching that for sure. Okay, so talking about Kafka and the load testing, I have in the thumbnail, you're gonna see that I have listed the Kafka and what else was there? Gatling and the Postgres. This is eventually gonna be the setup we're gonna be evaluating. But before we do that, we are performance testers. Most of us are, I guess. I've gathered you from LinkedIn. And so that's our job is mostly to assess the capacity of the system, but also their efficiency of the flows, but also the latency, right? And the latency in terms of Kafka flows and services that use Kafka are a bit tricky to manage. So I'm gonna talk about this in this chat, right? So talking about latency, especially when we think of end-to-end flows, um, this is something that normally is somewhat neglected, meaning from the end-to-end perspective. First reason for that is most of the flows when we talk about asynchronous processing, it's usually a producer sending the message somewhere. Uh, by the way, this is my best guess, like best way to animate stuff using Draw.io. I hope you like it. Um, so my when we send the message to the what do I want to send those? Okay, save changes. Click it. So when we send the message to the Kafka for the producer, this is usually a fire and forget setup, right? So let's usually when we have a like producer and multiple consumers, especially when we have multiple consumers, we don't wait for any acknowledgement from the consumer side, right? So on Sunday stream, I've talked about the separation of the consumer and producer from the flow, so they don't even talk to each other, right? So and they're not even aware of each other, right? So there's unlike the protocols like HTTP or MQ, um, there is no communication between the consumer and producer, right? And you can have actually multiple consumers consuming the same message, right? And there's it's totally fine. It's totally okay for you. There is a setup, for example, when a producer sends a message to the topic, and then I don't know, this is the application, web application sending the message. This would be, I don't know, the warehouse picking up the order. This would be the accounting, um, doing the accounting of some order, and this is some other external system that dispatches, I don't know, for auditing or whatever, or for reporting, right? So this is the usual setup when you think of the Kafka flows and messaging, right? And this here, each of the consumer can pick up the same message, and that's fine. What I want to cover specifically is a flow where you have a single producer, a single consumer. So you have a single producer, single consumer. But the thing is here, this is going to be a request, and also going to be expecting a response back, right? So this is the request reply flow from us. So the producer sends the request, consumer reads it, and eventually it's gonna produce a reply. Right? So the roles would turn, the consumer will be the producer to send the reply, etc. Right? So not unusual, not a usual configuration of the flows, but also it's not a uncommon for transactions when we want to when we care about the resilience of the whole application, right? Kafka in itself is highly resilient, and you don't have to worry about loss of messages, right? Because of the persistence of the drives, um, any consumer can pick up any message from the topic at any time, right? So we can guarantee your quality of service. So the quality of service is going to be the topic that I want to cover here. And this is going to be the flow I want to touch today. Cool. So, starting from the producer sending the request, right? Let's forget about the reply right now. So, starting from the producer sending the request, what makes the end-to-end late? Oh, no, actually, you know what? Let's leave it here. What makes the end-to-end latency actually coming from the producer producing the message up to the consumer sending response back, right? Um, I've covered this is again. I'm going to cover coming back to the Sunday stream, but I've covered the way that the consumer and the consumer group specifically post the messages from the topic, and each of them leaves a mark where with the last message it had read. Right. This mark here is called the consumer offset. So and this reflects of the last message that was consumed. Right. So in case of any disturbance from the service, uh, next consumer can pick up this message, right? So we've talked about here in this context, and also that the fact that each topic can be and should be split into partitions, right, for maximum throughput and of the processor. So let's talk about the end-to-end flow, right? The producer can produce a message, right? So for simplicity, I'm going to be using the Java clients, not other ones, mainly because I'm mostly familiar with Java clients, but also like this is the easiest way to visualize it, right? So the producer starts with producing a message, right? Message contains some payload, right? This is right here in the envelope. It also contains some headers, right? So the headers are actually some way of communication, just like the ones you're going to have in the HTTP protocol. They're not as standardized as the HTTP. There is no, say, one set of headers you want to set, but headers could be like, hey, where should we reply go to, right? So I want the response topic to be like this, like response topic, right? Uh, and also various ones to notify the application what type of payload it is consuming, unless it's not necessary, right? So, but standard way is for you to send it up, to send the message with the headers. There's also the message key, right, which tells the identifier of the message, right? The key is not necessarily a string, like standard applications you're going to see are going to be with a string serializer of the key, but it's not necessarily the case. In any way, this is the identifier of the message. So the producer receives it's an entity called the producer record, right? Which is essentially your message. This contains those headers. This contains the payload. This contains the message key. Also, optionally, this can point to a specific partition, but I'm also right now straying from the main topic, right? So what happens when you actually produce the key? This is very important from the perspective of the end-to-end latency. So let's see if I can have some action location. Okay, I'm gonna use these for a timeline, right? So we're first producing the message. So message create producer record, right? This in any case doesn't do much. So this just calls this message in the memory before we even start thinking of sending it, right? Actually, before you also have the create producer Kafka, so Kafka producer, this will be called. And we have here the Kafka producer. But Kafka producer actually is going to be created like once in a while, right? You don't have to create a new producer for every message you send. That's a bad practice, very bad practice. So you have this producer, and we're gonna use it here, right? So we first produce the producer record. When we're ready to send it, to send this message, we use the producer send. Send, right? And this is where things get a bit weird because the sending process is fully asynchronous by default, right? So by default, the producer does not send those messages immediately. There are a few things that have to happen before that, and also this is actually the main power of the Kafka throughput and high throughput, low latency feature, like relatively low latency. But because it's asynchronous, the producer can do a few things in between, right? First one is called the batching of the request. So it actually requests batching. There are two properties that decide how many messages will be batched for a single batch. First one is batch size. So this reflects in the either in bytes or in a number of messages. Maximum number of messages the producer will wait for until he sends the request. But there's also a um, linger parameter that defines also that the time that producer will wait for this amount of time before it sends all the messages it had accumulated. This is very important because all of those parameters they directly impact the end-to-end latency, right? So you want to, like most of the cases, you want to leverage the batching of the producers and make sure that you effectively send those requests, especially for high throughput transactions. But also, you don't want them to wait forever, right? So those two parameters would affect that. Before actually we do with only batching, there is one step that is done here, which is a serialization. So this effectively converts the it actually might be somewhere here, not sure. This serialization takes care of the serialization into the bytes. So if every message you're going to see in Kafka flow, this will be in form of a byte string, right? There is no string here or no one structure that the messages will be read to. So that's why it's important to specify the serialization. The most common formats of the Kafka messages are string, so you can always send a string to the system. But also, if you want efficiency, you would probably look into the protobufs and Avro messages, right? So serialization happens here. Then we send the message. Producer waits to batch for some time, right? So this can be on the timeline. This can take some time, and then it gets actually sent to there's a network thread. Actually here, if I can visualize it somehow. So the network thread dispatches this message later, right? Network thread takes care of streaming the message to the broker or to the brokers. Because the thing is, when you create the producer records, you specify how many brokers you want the acknowledgements from, right? And when we talk about acknowledgements, like for example, you have a highly resilient setup, you have a multiple brokers that can handle multiple partitions and topic replicas. Those brokers can fail. Each of them can actually lose its position as the partition leader. So it's important to understand the impact of the resilience of a system when you send the messages, right? This has the most impact on the quality of service again, right? Kafka is one of the protocols that doesn't guarantee exactly once delivery or even at least once delivery or even at most once. This means you can have duplicate messages sent to the topic. You can have missing messages, or if you are if you want high resilience and high quality of service, so exactly once, you have to also take into account the increased latency of the service, right? So the network thread sends then the message later to the broker, and here is actually where the magic happens on the broker side. Because the broker has a feature called and this is the main backbone of Kafka, at least until the most recent version, because the most recent Kafka version is diskless. But the main feature up until now of the Kafka brokers was a zero copy strategy, right? So zero copy. What this essentially means, and this is a optimization feature. Even though we are using hard drives, we are using presumed one of the slowest components in the system, Kafka still managed to maintain relatively low latency with a replication of those messages by preventing a copy from the kernel space to the user space. So the broker effectively receives those bytes, these messages via the network, and immediately persists them on a drive, right? So this is how the Kafka maintains its own relatively low latency, even though the messages are persistent on the drive, right? So the broker does its zero copy, it persists the messages on the disk, and also there is a factor of replication, right? Replication, this depends on your setup of the producer. If you want to wait for the replication to fully happen and to be fully committed, then this also affects your latency, right? So if you want to set up your producers with maximum resilience and to make sure that you have exactly once delivery, this is the factor that is going to affect your latency the most, right? So you have here the replication fact, and after that, there is a consumer process, right? So these are, okay, let me just quickly patch those together, which components belong where. I'm gonna put these here. So this is the broker that does that. So it does the zero copy, does the replication. All of those processes, I'm gonna batch them here. They belong to the consumer, to the producer, sorry. Okay, these go to here. Producer, broker, and there is the consumer, right? So I'll talk about it here in the end. Consumer also has a network thread, but it does the fetching. Unlike MQ protocols or HTTP asynchronous thing, the standard implementation of the Kafka client actually is fetching the messages all the time. That's like on the background. There are multiple configuration items that you can set to limit this fetching or to increase the number of messages. But this is also not exposed to the end user or to the user space. This sorry, this is happening on the network level. So on the network thread. Network thread is constantly fetching these messages, and then later on, there is an action called the polling. Right, this is something that you, as an end user, will be exposed to, and this goes here. So this is a polling of the message, right? So and they all belong to the consumer. I'm gonna also add those here. Consumer. I'm gonna put these to the background. Okay, great, guys. If you have any questions that if you have something popping up here, just type them in a chat. I try to read these. Hello, everyone, by the way, who just joined. I try to read these as I'm just typing. If you guys have any questions, I'll try to address them. The reason I'm writing and drawing it here right now is for you guys to ask questions, and I can just pick this up. I can then draw those diagrams for you to understand. At least I'll try my best to do that. Okay, so fetching, there is a polling of messages, and this is where the consumer actually can do one step. The order of those transactions of these two that I'm going to show depends on the requirements of your resilience, right? So you can have a polling of the messages. You can process this message. You can process this message, but you can also immediately commit, right? This is um, order of commitment of the messages is relevant to the resilience of your setup, right? In case you lose one of the consumers from the consumer group, let's talk about here. In case you lose one of the consumers from the consumer group, any uncommitted messages, right? Let's see, this consumer is going to pick up the new message, the messages that this guy have not. Any uncommitted messages will be um, reprocessed by any other one. Where the back follow question, where we can check back pressure is created in Kafka flow. This is a great question. On Sunday I've covered the KPIs, meaning the lag of the consumer and the replication lag. We're gonna talk about it later on. Okay, is that fine? About the back pressure. Okay. So this consumer, is going to pick up any messages that were not committed. Um, so let's say the other guy left it here. What is zero replication copy? Zero copy is a mechanism implemented by Kafka to not copy the um, do not copy the messages from the kernel space into the user space, right? This is where, like, when you copy the data from the network, so from a network interface card, you can copy them to RAM and then be exposed to the user, or you can also just straight forward them to the disk drive, right? And so effectively, instead of having a copy from the network to the user and then from the user to the disk, they just go straight to the drive. I think it's an IO library that it uses underneath. I'm pretty sure. So the NIO, the new input output, these are the buffers that effectively act on the kernel space. You can read about them also. So okay, back to the process of consumers. The commit here is effectively your guardian for the delivery and for making sure you don't have any duplicates processed of the message. But also the order here matters in this context, right? So you can have here the commit. You can even put this process, like the commit, to be fully asynchronous, right? So from the polling, you can have a, how do I do a, how do I change the shape here? I don't even know how to do that here. I think I've lost some of part of the screen. Okay, so you can have a commit, and this commit will be fully asynchronous, right? So it doesn't matter where you send, like whatever, how many messages you have processed in the meantime. You can just make sure that the commit is going to happen at some point, right? Effectively, again, this all makes sense, and this all affects your quality of service, right? There are some applications that can handle duplicates messages very well, that the messages can be missing, and that's totally fine. What we as performance testers should validate and acknowledge is the amount of messages that were actually lost or duplicated, right? And so my experience with that is I have seen more than two cases that I had the exact same number of duplicates and missing messages, right? So that's just my experience, but two is high enough for me to consider my strategies for testing the services using Kafka. And that's why I've came up with some ideas right now to implement with load testing tools, right? Okay, so we have the full flow of the producer roughly. There's also compression here, right? Okay, I think I forgot about the compression. Paste it here. the Kafka is compressing the messages here. So you have the full flow of producer. We have the like this is very simplistic way of describing the broker, uh, but and this is the factors impacting the latency from the consumer side, right? And like unlike the HTTP protocol, when you have it fully synchronized, these processes are fully detached from each other, right? So this means effectively we cannot have a single thread that is going to wait for a message and for to measure the full flow end to end, right? This is why we have a challenge. Actually, I have to put those actually maybe here. I have to slightly move all those because they do not touch, right? They are connected from the business perspective, from the business case, but these processes do not touch with each other, right? And this is the challenge of measuring the end-to-end of the message itself. But we can talk about this as well, right? So effectively, from here, the processing of the message can adapt to the like. Of course, I think right now, if I do it like this, the processing of the message would most likely be the most expensive one, right? So only if I was to do something, to visualize the time on this timeline, which process takes the most, this will be the processing of the message, right? You have to make sure these are persisted, these are acknowledged, and then only then you can commit, right? The thing is here, unlike the let's say transactional scopes on the MQ side, the commitment of this message doesn't do anything to the producer. Right? Producer can send the messages all the time, can be fully unimpacted by any other actions unless there is some delay coming from the broker, right? The same with consumer. Consumer will just like if you specify right, the consumer will just pull the messages um, constantly from the server, right? This makes this is what makes the Kafka high throughput system, right? There is nothing that can block the processes of the producer and the consumer, effectively having a full producer consumer setup, right? If you want to go the other way around, right? So you have a when we're talking about the request and response, exactly the same process happens. Uh, exactly the same process happens on the way back, right? So the producer sends the request, consumer consumes them, and then it follows the same process here with one main, let's say, difference. The key to this message is effectively a copy to of the request on the standard say implementation, right? So the key gets copied from the request. Just move it here. The key is copied from the request to the reply, right? Effectively, you can read and map easily the request with the response. There are some systems that do not support the matching of the keys, which makes the matching of the messages a bit harder and more tricky. But the standard for the Kafka implementation, specifies that the key should be copied so that the messages can be copied over, right? Um, this is these are the things that affect the general end-to-end latency, right, of the message. What we can measure from any producer side is steps from here up until here, right? So up until now, actually, from the producer record, we have a means to measure that up until the replication, right? So I just see if I can just do it like this. No, this will not be. have to draw it somehow. So again, producer, if it's specified right, it can measure up until the replication, right? There is no way to extend this measurement of the producer itself. The consumer, on the other hand, can measure the steps from where the first copy had been received to up until it commits the message, right? Also, okay, this is not entirely true. There is a way actually in the standard Kafka implementation that the producer record creation creates a timestamp, and this timestamp is persistent with the message, right? So if you want to, for example, measure the end-to-end flow from creating the producer record up until even the commit here, you can do it with the consumer using the timestamp specified in the topic configuration, right? There are two options for the Kafka topic configuration. First one is using the producer record timestamp. The other one is to have the log append time. This is the that's how this configuration is called, right? So depends on the configuration of your topic and on the use case. You can have either timestamp embedded here or the timestamp embedded here, right? Totally up to you. And I myself have found the broker timestamp to be more useful because I can define from the application on the application side, I can easily validate and persist the date that I have created or sent the message, but it was hard to determine exactly the log append time, right? Not the replication, but how when the first replica leader had received the message. So all of these processes make measurement of end-to-end transactions very tricky, right? So there is no one best way to do it. And this is why the load testing tools don't have a full support of end-to-end transactions, right? And even less options for supporting the request reply flows, right? This is where I think I should mention that there are some options, and there is one plugin in particular that I have found very useful for that. And this is the plugin from Pavel, I don't know his name, sorry. Byrov was his name, I think. Byrov, yes, from Pavel Byrov. And this is the only plugin I'm aware of that actually can help you persist those messages and measure the transactions end to end. I'm gonna tell you about this plugin shortly and some of the limitations that I have found. We may actually fix later or try some alternatives for that, right? So the plugin that Pavel has allows a timeout, right? And the way it actually works for a transaction with a request, like we request with reply option, is quite and like say trivial, but also genius in its implementation, right? So going back to the draw.io. So Pavel's plugin does a thing like this. So when you have a producer record, when we actually send that, it persists. It actually blocks the thread and stores the information of the thread. So like this message sent, message and thread, and this message, this thread is actually waiting and it's locked until we got the message back, right? So, but the producer itself does not have anything like in the middle, right? So actually what it does is the consumer. Let's assume we have a request response flow, right? So the consumer then sends a signal to this thread, so the signal that the message has been processed, right? Effectively, this is an implementation of the after we send the message, we lock the thread, we measure the time. This is where we start the clock. So should be a clock there somewhere, right? We start the clock, start the timer, and then once we receive the message back, so the response, it stops the timer, right? So effectively, the only plugin that I could find that can measure this stuff freely, right? All of the other plugins that I found on the internet were focusing solely on load testing the Kafka system, right? It's not bad at all. So it is important to load test and measure the capacity of your Kafka flows. However, there is also the context of the end user and how the external application will handle the latency of your whole flows, right? And this means what exactly was the impact of everything here, like including the configuration, including the time it took to commit, the message processing, etc. Right? How much time it took to poll the message, etc. Right? So these all effectively maybe you guys know, maybe you guys have some ideas, um, or some other knowledge of other plugins, but this is the only one that I could find that actually measures the flows end to end, right? So it has some disadvantages, I mean limitations at least, that we should mention. So if we keep the stop on the if you keep the messages on the thread, there is no guarantee that first of all there is no scalability, right? The way the Kafka works, meaning for the partitioning of the messages, it is not guaranteed that you're gonna get that the same server that had sent the messages back, that had sent the messages, will also receive a corresponding response. Right. This is one of the limitations of the Kafka flows and the and of Kafka clients, that it is not guaranteed that this producer that had sent the message, the consumer had picked it up, that the response is also going to land on this producer, right? Because the many things can happen on the go. The many things can disrupt the application. You are most likely okay, if there's a question here, if the producer and consumer are both two different systems, will the thread locking concept work? Yes, I mean, okay, so the idea here for at least for the request response, right? So we said the request and the response here. There is a producer, and you can put a consumer also on the same server, right? This is one of the limitations of this plugin, that you actually are basically constrained to a single server for any load test, right? For most of you, this will not be a problem. A single server, at least like from the Gatling perspective, it's more than powerful to maintain to meet your needs of the throughput. But again, if there are two different systems, then this will not work, right? That's a very good point, Sikora. So the idea here is it's only going to work on a single server load test, and that's it, right? The trick begins and the problem starts when we want to have multiple servers, right? And this is for various reasons. The implementation can handle, for example, different hardware, different architecture, and is solely dependent on how the end users will work, right? This is where the consumer groups also come in. But one of the main one of the main patterns you should know for a distributed messaging of these transactions is an outbox pattern, right? So this effectively, see if I can zoom out here. So instead of locking a single thread, right? Well, what the outbox pattern does, this is one of my favorites. So instead of locking the thread here and locking this here, we're going to store the request details. Okay, of the producer in a database, right? So this effectively doesn't do a thing. We're going to store the request details in the database, and then when we receive the message, we can extract this same message from here from the database and do all of sorts of things, right? First of all, we can measure the time as long as we just forward the timestamp of the message itself, or when we think it was sent here. If we persist in a database, these details will be here, right? So effectively, we compare the wall clock here, and this is going to be wall clock. I don't think you're going to see anything here. Oh, okay, sorry for the zooming in and out. Also, I should move myself here. Now should be good. We're gonna have a wall clock here. We're gonna have a persistent time, and this is how the process will measure the end to end, right? With persistence on a database, you can also do a thing that was not possible when just locking in a thread. And this will mean all sorts of assertions, right? And this, I like the idea of asserting a request in the context of asserting the response message. Not here, sorry. So when you send the request and we got the response back, I like the idea of persisting those because you can then assert the response in the context of what was sent. When we talk about distributed systems and the protocols that are asynchronous, they do a lot of tweaking, handling. There is a higher risk of having some form of race conditions in the flows, right? And when we talk about race conditions, and you look at the books of what's available and what are the resources available, guys, I think my screen had locked, and you guys haven't said a thing. Is that correct? I'm pretty sure my screen is not visible here. Yes, I think it just broke and it just crashed. You guys have not said a thing. And I was just drawing like crazy here. Okay, that's actually pretty embarrassing because it crashed for the second time. Still here. Yeah, I know, but I think the screen here is slightly broken because I just look at my screen and it just shows a different picture. It's let me reopen the OBS Studio, right? Just give me a second, and because I want you guys to have the best experience. Maybe I'm just gonna change the screen values properties. Just give me. Maybe I can just switch to the other screen. This should be better. And now you guys should see me as well. Okay, sorry for that, guys. I have not noticed that the screen was lagging. I'm gonna have to see what I can do later for these messages. Okay, so why the persistence on the database again? Because we can assert the request in the context of the sent request, right? There's a high risk and the higher than usual, and when we talk about the asynchronous processes and promises and futures and stuff like that, that we actually miss some things, and that the request goes into the wrong place. When we talk about the race conditions, it's when you read about race conditions, you're gonna read about some obfuscated integers that cause segment faults, or the other stuff that that happened on the single register level on the CPU. This is all true, but also the race conditions can happen with a single pointer, right? If there's a fight for a pointer to any object, let's say a response object, then they may get swapped, right? And this is what I prefer to store and persist the request in a database. So then I can, validate that, do some simple checks, extract the whole request, and get the data like who's the sender, and then should this recipient receive it. And this is something that doesn't normally, that you're not normally expected, but if you work for some highly critical applications with like exactly once delivery, but also they do a lot of confidential data or some GDPR stuff, then these are the exact validations you should be checking, right? I know this is not a standard way of validating that in a context of the in the context of the HTTP protocols. It's easier because most of them support this synchronicity, so you can easily do these validations. And what is wax? I think I've just chopped. Um, but in context of the asynchronous transactions with the response back, like I personally would want to assert that, especially for the highly critical systems, right? When you are streaming, I don't know, like some, um, let's say coordinates from the system, do some IoT stuff, then it probably doesn't matter. But when it comes to the and you can easily dispatch, and actually you should train your application to dispatch some irrelevant data. But when it comes to some critical messaging, like it's better to be safe than sorry, right? It is more expensive, of course. I agree with that. It's in terms of the hardware cost, because you actually will have to maintain your own database for that. This is what this invokes higher cost on that, but also this makes sure you can save yourself some time on validating a few things, right? So these things are, when we are effectively using the outbox pattern, first is the quality of service, right? Quality of service, and this means you can easily and without any help, any need for manual actions, you can validate the number of messages process. Uh, Number of message process. You can count the duplicates immediately. They will just be shown to you at the runtime. Duplicates and missing responses, right? What else is there? Advantages. Well, the two is real or close to real time measurements. So immediately you can just validate your latency when the test is running. Sometimes, and if you have run any test, you know that you sometimes just want to stop your test immediately. When we just push the load to the system, um, when we just push the load to the system, and there is no stopping there, there's no validation of that. More often, you'll find that the test was just completely invalid, and you have to start over, right? And the sooner you can validate those metrics, the better for the health of your environment, right? So we have the closed real-time measurements and advanced assertions, right? So in most of the cases, and I would normally show you guys how this thing works in action, but I'm not very fluent in not very fluent in the Scala at all. So I'm sorry that I won't be able to still to show you this, guys. But I have some other thing I can show you that I have already started, and this is for my own. I mean, eventually it's gonna be for you guys, but I've started the development of of a similar tool with a few exceptions. Mm-hmm. So this is the time where I'm gonna be talking about the code. Sorry for that. If you guys are interested, and I really appreciate that you guys are staying here. I see that you guys are active. I see that you guys are on the chat. I really love you guys. Um, so uh, started development of this plugin here that would like mostly focus on the business side of the Kafka messaging, right? So it's not going to be a tool that you can just push any load to the system and expect the full measurements. I would rather focus on the business side, so the actual impact on the end user, so on the end-to-end message from the consumer perspective, right? Um, that's something that I like. Only Pavel really does it, but also I want to make it more scalable. I want to make it more suitable for resilience tests. So I want to actually be able to simulate the outage of any brokers, of any consumers. I want to measure the impact of rebalancing of the system, right? This is with um, at scale, it's not possible with any of the tools, right? So let me see if I can actually join it. Validate whether my server is working and that I can actually start up some tools. So I came up with this idea that is very similar to Pavel's, but it does like it supports a multiple multiple options for persistence of the messages. Right. First one is in memory. So similar to Pavel's, you just if you just want a test with a single instance, you don't want the fuss of setting up the Postgres or whatever database you want. You don't want any maintenance with that. This is also doable here. So you just store those in memory, but with the constraint that you're actually limited to the you're limited to only a single server for execution. The other one is with a Postgres, effectively. So it does store a few data, and probably I'll do some modifications before I actually publish that. So it stores the entire request with this correlation ID, with the key. It's actually the separate IDs, with the message key, with the values, and what's the transaction name. The transaction name is actually very important because if you have a distributed consumers and your consumers do not um, can consume from multiple topics, for example, then you have to match the transaction name somehow for the reporting, right? So this effectively is just storing the request here. Um, then the consumer side of the test is getting the request back and then does the matching and the validation of that, right? So to extract the request, I have not done the transacted context yet, so the for update will actually not work here. Um, you guys are here. I'm just making sure that you are, and that I'm showing still something. So they, and actually, if you guys would have notified me, I would have known that my screen is limited because I've just briefly fixed that. Since I'm using a different screen resolution, it appears smaller. So I have to expand it somehow. Okay, now it should be better. Sorry for that, guys. Again, I was not expecting to stream from the other monitor. Okay, so we have the extraction of this request here. Uh, Effectively just getting the connection, getting all the details, and then run some assertions. Um, and I've already running a test, a very simple one, and only sending the string messages. But what it does, and this is kind of request simulation here. What it does effectively, it just sends the one message to the request topic. The consumer group, which is a fully independent process, um, this process is actually, guys, I think my whole screen just froze. My camera froze now. Okay, that's a bit embarrassing. Let me just to camera hub. Let me see if I can fix that somehow. I suppose not. Okay, so my camera froze. Let's see if I can switch the screen scenes. I'm sorry that I'm doing all the troubleshooting, guys. I'm really am. Just a. It's a completely new setup that I have here, and I'm still in the process of troubleshooting. So the deal here is you guys get the knowledge for free, but I get to troubleshoot it on live system. I guess. Yeah, my camera just broke. Okay. It doesn't matter. You don't want to see my face anyway. Um, so back to the scenarios. So I'm here sending my messages to the request topic to the and I'm also listening to the same topic, right? Using my Kafka protocol. I know this is something that I have to still work on. Gatling is a bit new to me still, so I have not used that for many tests or for any actually commercial tests at all. And I want you guys to have the best say experience with that as well. So this is a bit say constraint, um, and I also want to follow their practices, right? So I may be in touch with the Gatling devs to improve that somehow. And then the scenario looks like this, right? So we have the injection of the messages. I'm writing up the users, like from 10 to 1,000 within 60 seconds, then 1,000 users for 60 seconds, and then back from 1,000 to 10 in another 60 seconds, right? Um, a very important part of this flow here is to do nothing for the duration of a timeout, right? So there is also a background process that measures the timeout of the transactions, and this is very important because if you do not wait with your system, you will not also you'll be missing any potential timeouts that have occurred after your test had concluded. You know what, guys? I think I can just change a camera. It should help slightly. And you guys should see at least me or myself and I. Okay, just give me a second and I will show myself here under some different setup. This is my OBS. I'm gonna change the camera. That's a different angle, but you guys should see me now. Why is that the black screen? I do not know. I'm gonna take off the anamorphic lens that I have here, and we should be back live. Yes, I really hope we are. OBS says we are, but you guys have some lag in the screen. But yep, okay, now it should be good. I don't even know how often I'm gonna apologize for you to you for that. But let's go back to the topic. We have here a protocol of the Kafka, right? And if I right now try, okay, it did actually compile. I think it did. It did compile and it did the test. I should be able to open the generated test file. Is that correct? Okay, edit is in the target Gatling. Shouldn't be in the generation log, it should be in the index. Where is the last one? I did a few test runs, as you guys can see. Try to open that somehow. In the browser, guess. Okay, so the report that it generated, I was running everything locally right now. My Kafka was running locally. And what? I think I'm just gonna have to shut down this lamp so you guys don't actually. Okay, now it should be better. So the report itself is going to contain all the requests and the duration of end-to-end flow, right? So even though I was sending messages to the single um, topic, we can measure the end-to-end time, which is the full request reply action, right? I was storing the messages in memory, so I was constrained to a single server to run the test. But also, once I fixed some of the timing issues and some of the problems I had, we can also measure the end-to-end flows, right? So in here we can see the number of requests per second, number of responses per second, right? The test actually should take 2 minutes. But all in all, you're gonna have the full description and full the end-to-end flow that I'm aiming for. That's pretty much it. If you guys have any questions for that, just let me know. Just drop a comment here, and I will be happy to answer. I know that we are past the scheduled event, so I understand that you guys have families. I also have mine. My wife is with the kids. Thank you again. I hope she hears that. So yeah, this roughly is what we would expect. A few things that I have found still not quite there and should be doable, at least technically, but it's, I think, mostly for the enterprise platform of the Gatling, would be to adding the JMX metrics, right? When we look at the Kafka JMX metrics list, right? Okay, the Confluent documentation has a very extensive list of those. When we talk about the metrics itself, there's a huge, and I mean huge list of all the metrics we want to capture, right? I'm not sure how extensive the enterprise platform is for the support of metrics over time. This might be something then for you to consider some observability platform to have, but the amount of metrics you can have for all these components is enormous, right? And from the producer metrics, okay, these are the producer metrics here. Um, you can measure the entire latency as well in here, right? So metadata age, you can get the error rate, so the record queue time, so how much time you can spend on the queues internally, how many retries have the record has tried, what's the retry rate, what's the size, the average size of the request, right? All of this stuff that are very helpful um, for the production, you could also leverage in the test, right? So again, I don't know whether it's supported. If it's not, then probably an exposure of these metrics to your observability platform, that would be something to look at, as well as the consumer metrics, right? Um, how like the when was the last poll you did, what's the fetch rate, so we'll talk about fetching as well, what is the lag, what was the maximum lag, what is the average lag for the topics and for each partition. This is all exposed by those GMX metrics, so you can also look into that from the in the embeds, right? I'm guessing you guys know those metrics, the JMX, I mean JMX itself. If you do not, then well, these are managed beans from Java, right? So Java allows this metric extension, so it's called Java metric extension, and it allows you to capture or to fetch various metrics and that you can just plot or chart or get some data out of it. Very useful stuff, very go to use. There's never enough data. Like trust me, when you do a deep dive troubleshooting, there's never enough data that you can collect with those. Some of the platforms do it good. Some of the platforms, well, there's a lot of manual effort to that. But in overall, these are the things I would also plan to expose somehow. If not, we'll just add them to some observability platform. One that I have played with and that I have found working out of the box with Kafka was the Sinos or Sinos. I like the Sinos better. Like the thing at the end is like the Spanish end. So I'm gonna just pronounce it Sinos. Um, but just as soon as I have installed it for my local Kubernetes cluster, the thing just worked, right? So all of these metrics actually were greatly and beautifully plotted um, into the system. Guys, I'm gonna switch the cameras, and I think it's time for us to pause. Um, at least slightly. Let me see if I can just talking head. Can I move myself here as my camera? Can I even do that? Yay! It turns out I can. Okay, so I think it's a good time for us to finish for today. I will be continuing, and if once I have anything actually like working to show, because I don't want to push out any plugin that doesn't work or supports only a subset of functionalities. So I'm gonna be working on that. Probably I will be also streaming the progress or vlogging it live, to see how I tackle certain problems, how what's my approach for that. If you guys are interested, then you are welcome to subscribe to the channel, and I will probably sending out some invitations on LinkedIn as well, so you guys can join me with those efforts. The repository is deliberately not opened, so I don't share this code anywhere until it's done. I believe that the sharing of the code publicly when the product is not ready may do more harm than good. Until it's actually usable and until we sort this out, I'm gonna leave it as closed, and we'll get. But eventually, the aim is to open source it, so that you guys can also take leverage of that. If you come up with your own ideas that are better, that are more suitable for your needs, and you guys want or have some specific edge case that you cannot handle, you can also either build your own or contact me. Maybe there is some way to overcome this. In any case, I thank you very much for your attendance. I see that there is a lot of people actually watching that on live. We've been here for 75 minutes and I was talking constantly. I'm not used to that very much. But any case, thank you very much again for tuning in, and I appreciate your coming in. So I'm gonna set up some invitations for the later streams. I have to, of course, synchronize that. There's a whole family waiting for me and stuff. So I'll try to somehow squeeze this into the some regular schedule. Thank you. And now I have to learn how to end the stream.